Welcome to the pre-lab video for the electroscope experiment. This experiment's aim is to introduce some physics concepts into your chemistry knowledge to help you out with the quantum theory aspect to your course, namely the understanding of the quantum numbers and the electronic energy levels. This part is going to tell you what to do in the experiment and also how to build your own electroscope. The experiment demonstrates the photoelectric effect. The photoelectric effect is the emission of electrons from a metal surface when they interact with electromagnetic radiation. The particular effect that you will observe in the experiment that you're going to carry out is that electrons cannot be emitted when they interact with visible light, but they can be emitted when they interact with UV light. These are both forms of electromagnetic radiation, and this effect shows that this radiation must exist in quanta. Your task for the experiment is to explain why we observe the emission of electrons with UV light but not with visible light. And you must use the wave and particle models of light to explain yourself. What I mean by electromagnetic radiation and all these terms and the models that I've talked about just now are outlined in part 2 of this video, so don't worry if you're very confused right now, wondering how you're going to do this. This effect left many scientists confused in the early part of the 20th century, as they couldn't explain this effect with a wave model of electromagnetic radiation. This was ultimately solved with Einstein's quantized particle model of electromagnetic radiation that could actually explain this effect. It was actually this theory that won Einstein himself a Nobel Prize in 1921, and this birthed the creation of a branch of physics known as quantum mechanics, which ended up having an enormous impact on the world of chemistry and actually on the world as a whole. Okay, so back to your experiment. To carry this out, you're going to need an electroscope, and you guys are going to have to build this yourself. This is really easy, and all you need is a glass jar, electrical tape, some electrically conductive wire, aluminium foil, and some waste cardboard or plastic. To begin with, you're going to get your wire and cut a piece around 30 or 40 centimeters in length. Now you want to coil this wire, leaving about 10 centimeters that you can kind of bend straight. Next, you want to get your aluminium foil and cut 2 small teardrop shapes from it. And you want these to be about 1 inch in height. Then we're going to insulate our electrical wire that's been coiled up in the parts that are going to be in contact with anything. To do this, you just want to tape up a little part, about 1 inch long, underneath the coil you've made. I've used the plastic insulation from an old wire to do this, which will work too. Now you want to cut your cardboard or plastic so it will fit nicely on top of your glass jar, and we want to poke a hole in the center of this so our wire and the insulation wrapped around it can fit through. So put your wire through the plastic or the cardboard with the hole in, and you want to make it sure that its contact sits on the insulated part. Now bend the end of your wire to make it look like a hook. We're going to then stick our aluminium foil through the top part on the end of this hook. Place the whole thing on top of the glass jar so the aluminium foil is now hanging in the center, and you don't want it to be in contact with any of the edges of the jar. So you might need to make some adjustments of how the wire sits and how it's bent through the hole. Take the cardboard or plastic onto the jar once you're happy with how it's sitting, and this will just stop it moving around. Now you've made yourself a DIY electroscope, and we can begin to charge it up. To do this, you want to rub a perspex or vinyl rod with a piece of cloth. You can even use a balloon rubbed on your shirt if you want. Then bring this charged rod next to the coil of wire without touching it. Whilst the rod is near the wire, touch the wire with your finger and then take away the rod quickly. This will leave your electroscope charged up, shown by the sheets of aluminium foil repelling each other. What we're doing by charging it up is transferring electrons from the rod to the wire, which travel through down to the aluminium foil. This will mean that there are now more electrons than protons present in the chemical system of the aluminium foil. As the electrons are negatively charged and the protons are positively charged, the excess of electrons will result in the overall system having a negative charge. Like charges repel, so we see the aluminium foil sheets repel each other like so. By shining radiation on the wire, we're transferring energy to the electrons that are within it. They're originally in their ground state. It's just the lowest, most stable energy state of the electrons. This increase in energy can be represented as a promotion through the electronic quantum energy levels. Electromagnetic radiation with high enough energy will give the electron enough energy to overcome all of these energy levels. We can see this through the promotion from this bottom electronic ground state all the way up to this red energy level here, which represents the highest energy level possible. The levels basically just represent the energy of the attractive forces pulling the electron towards the positive charge of the metal nucleus. When the electron is promoted to an energy higher than this, we see emission of the electrons and a discharge of the electroscope. We know this has happened when we see these two sheets of aluminium foil come back together, showing there's no longer an excess of electrons or a negative charge throughout the system. So now it's time to move on to the second part of this pre-laboratory video to learn a bit more about electromagnetic radiation and the terminology around it. It is really important to understand this experiment and the quantum theory part of your course.